Identifying polynomials. First, we might need to know what a polynomial is in order to identify it, right? We might need to have some definitions to work from. Because we don't know what something is, we might need to know. So to first state, we actually need to go back even further and talk about a monomial. We talked about monomials very, very, very briefly the other day. Back when we did 7.2 on Monday and Tuesday, we talked about monomials. So we're going to talk about this a little bit more. A monomial is a number, variable, or a product of a number and one or more variables. It's a number, a variable, or a product of one or more variables. A number of one or more variables. Mono means what? One. Okay? We're talking about one term. I talked about this the other day a little bit too as well. So monomials do not include denominators. They do not include denominators of a variable. What's denominator mean? The bottom of a fraction. So when it says do not include denominators of a variable, that doesn't mean it can't be divided by 2, but it can't be divided by x, or a variable. So it can be divided by a number just fine, but it cannot be divided by a variable and still be considered a monomial. They do not include addition or subtraction. Because as soon as you have addition and subtraction, you have a second term. Because that's what separates our terms, is addition and subtraction. And monomials that are called real numbers, are just called constants. You've heard us use that term before. Constants is when we just talk about the number without a variable with it. This is where it comes into play again. Monomials that are real variables, or real numbers, are called constants. Real numbers are called constants. So some examples of monomials. So underneath this examples part, we'll put some examples of monomials here. So some examples are 3. That's a monomial. It's considered a constant because it's just a real number. There's nothing else with it, it's just a constant. You could also have x squared y. X squared y. Is there any plus or minus signs in here? No, there's no addition or subtraction. We have a product of one or more variables. A product of 2 variables. So it's still a monomial. Okay. Another one could be 1/2 x, y, z. 1/2 x, y, z could all be one. Could be a monomial as well. Be sure to write this down. Be sure to write this down underneath your examples. 1/2 x, y, z could still be. Because we still have a product of a number, 1/2, and one or more variables, x, y, z. So it still can classify as a monomial. Now you might wonder, wait, I thought we could have denominators. Denominators of a variable. We can still divide by 2. What's a non-example mean? What does it mean for something to be a non-example?
1 plus 2. 12 plus 2.
Okay, so you guys are thinking of non-examples. That's awesome. So what's it mean to be a non-example? What does that mean in general?
It has to be.
So the example is something that is true for this, right? So the non-example would be something that's not true.
Yeah.
Does that make sense? Okay, so that's kind of what I was trying to get at that. But you guys are going next level with that already, which I love, and saying, hey, let's think it's a non-example. So one would be A plus B. What makes this one a non-example? Addition. Very good. It's okay that it has more than one variable, but it's addition, not a product. A itself, if we cover this up, A would be a monomial, and B is a monomial, but as soon as we add them together, not a monomial. They are individually monomials, but added together, this whole thing is not a monomial. Another non-example would be like 1 over a squared. Why is this one not a monomial? Being divided by a variable. We can't have denominators of variables. Being divided by a variable. That was one of our rules we had. So those are 2 non-examples. Grace.
I'm confused on how then half, 1/2 x, y, z.
Okay. So here, it says denominators of a variable. Are we dividing by a variable here? Is the variable in the denominator? No, so that's the difference. Very good question.
So could the a be on top then?
Yeah, Yep. So if you had one like this, you could have a squared over 4. That could be an example of one. And the difference between these two is where is the variable at? Okay, we can have variables being divided by numbers, but we cannot have anything divided by a variable in this. And I heard some other things of saying 2 plus 2. Okay, if we have 2 plus 2, can we actually just simplify that more though? What 2? So this would be an example. Because it can simplify this. But can we simplify a plus b? No, they're not what we call like terms. You guys remember that? Like terms? That word term is going to keep coming up in these because we call monomial a term. So if you flip your page, at the very top you have these 4 examples, and we're saying, okay, we're going to determine whether these are monomials or not. We're not saying they are or not yet. We're determining whether they are or not. We have to decide that and figure that out. So this first one, 8f squared g. Do we think that's monomial? Yes. It doesn't break any of our rules. It does not include addition or subtraction. There's no variables in the denominator. So yeah, I would say it's monomial. Okay, it's okay for us to have more than one variable. It's okay for them all to be multiplied together. That's fine by us. Make sure you're following along here, right? If you're following along, flip that page. We're on the second page of this part. 17 minus s. No, why not? It has the subtraction. Okay? It has subtraction there. So that tells us it's not a monomial. Very good. What about number 3? Yours has like nothing there. It's 3 over 4. So write 3 over 4 in that.
Right.
Okay?
Well, I just
Well,
put
that was
0
just
because
3.
0 is
That could be as well, yeah.
I
But
thought
here,
it was just 3, so I said yes.
so this one's supposed to be nice. Okay, so it's 3 over 4. But Sam says, yeah, it is. But Sam, we have a denominator. I thought we couldn't have denominators. You can, but only if they're number, right? Only if they're numbers. We can have a variable denominator, we can have a number denominator, which brings us to 4.
No.
No, why not?
Variable denominator.
Because t's in the denominator. It makes it not okay. Not a monomial. Makes it not a monomial. Very good, very good, very good. We're cooking.
Second one, I can smell the rock is cooking.
Ooh, there you go. Okay. What we're actually going to do is we're going to end these notes now. What I'm going to do is I'm going to talk with you guys individually real quick about just courses for next year, okay? Course registration's coming up. I don't know if the guidance counselor's come and talk to you yet about it.
No.
But we're going to talk briefly about those, okay? So, I'm going to ping around to your desk real quick and just talk with you real quick about the math course for next year.